Hi, welcome to Algebra 2 Common Core. Today in Lesson 6, we're going to take a look at solving rational inequalities. This is a rather challenging topic, so make sure that you're fully paying attention and following the notes step by step. We're going to start our work with rational inequalities with exercise number 1. So first of all, a rational expression is, of course, an expression in the form of a fraction, where I have a polynomial in the numerator and the denominator. This is an inequality because I see that in the first case, x minus 5 divided by x plus 3 is greater than or equal to 0. So the first exercise highlights the two components that we need to focus on. Let's look at Part A. In Part A, it says at what x value is the ratio equal to 0? And is this going to be part of my solution set? So we know from our previous work in rational expressions that in order to decide whether a fraction is equal to 0, I have to focus on the numerator. So I'm going to take the numerator, x minus 5, and I'm going to set that equal to 0. So again, my focus here is my numerator in order to have a rational expression equal to 0. So clearly solving this, I get x is equal to 5. Now when I take the 5 and I put it back in for x, I'm going to see that I have 5 minus 5 over 5 plus 3. That's giving me 0 over 8. And the question is this value, 0 over 8, which of course is 0, is this greater than or equal to 0? And 0 is greater than or equal to 0, so I'm going to say that yes, 5 is going to be part of our solution set. Let's go to Part B. In this part of the example, it says at what x value is the ratio undefined? Well, we've been working throughout this whole unit on undefined expressions. So we know that we have to take our denominator and we have to set our denominator equal to 0. So again, for the undefined part, that's where the denominator is equal to 0. So when I set x plus 3 equal to 0, I see that I'm getting x is equal to negative 3. Is this value part of the solution set? So I'm going to go back and substitute negative 3 into my rational expression. So negative 3 minus 5 over negative 3 plus 3. Is this greater than or equal to 0? Well, we see that this part gives me an undefined expression. And an undefined expression cannot be greater than or equal to 0. So we're going to say no, x equals negative 3 is not part of the solution set. Now in Part C, we're encouraged to use our calculator to help determine whether our test points are going to satisfy or not satisfy our original inequality. I'm going to focus on using our number line first, and then we'll take a look at the calculator after that. So the two values that I found in Part A and Part B, where the rational expression was equal to 0, that was 5. So let's go ahead and put that on our number line. There's 5. Let's also put the other number where the function was undefined, in this case negative 3, on my number line as well. Now we said that 5 is part of my solution, so that tells me that I am going to fill in the circle at 5, designating that 5 is part of the solution. But negative 3 is not part of the solution, so I'm going to put an open circle at negative 3. Now our goal is to test values in each interval and see if in the original inequality I'm satisfying this inequality. I'm going to rewrite the inequality real quick here. X minus 5 over x plus 3. We want the values that make that expression greater than or equal to 0. So I'm going to look at a value in each part, in each interval. So in this case, before negative 3, how about if we try the test point negative 4? I don't really care what the answer is. I just care whether the answer is greater than or equal to 0. We all know that greater than or equal to 0 means I'm looking for a positive answer or a 0 answer. So when I test -4, I'm going to substitute -4 in for x. -4 minus 5, that gives me a negative answer. So I'm going to write negative right here. The denominator, -4 plus 3, that also gives me a negative answer. So now I've got negative divided by negative. We all know that negative divided by negative is positive, so that tells me, yes, this interval does satisfy the inequality that the answers are greater than or equal to 0. Now let's try a number between -3 and 5. The easiest one, of course, to pick is 0. I'm plugging 0 in for x into this rational expression. So 0 minus 5, that gives me a negative numerator. 0 plus 3, that gives me a positive denominator. Now it wouldn't have mattered what number I picked between -3 and 5. No matter which number I picked, I'm going to get the same results. A negative divided by a positive is negative, and of course I see that that does not satisfy my inequality because I only want positive answers. I don't want negative answers. Go ahead and try a number past 5. So for example, 6. So I'm going to say 6 minus 5, that gives me a positive numerator. 6 plus 3, that gives me a positive denominator. Positive divided by positive is positive, so this interval works as well. Now, this says to go ahead and do our answer, state our answer in set builder notation. So in set builder notation, this would be the set of all x such that I want all the x's that are less than -3, or I want all the x's that are greater than or equal to +5. Now, if the question had told us to put it in interval notation, I just want to practice both notations here. In interval notation, we would say, let's start at -infinity and go to -3. Don't include -3, so put a curve bracket. Or I can also use the union set. I'm going to include the number 5, so I'm putting a square bracket at 5 and going up to +infinity. Now take a few minutes to look over that example and see all the different parts that we had to put together to see whether our inequality satisfied the original condition, in this case greater than or equal to 0. Let's try exercise 2A, which looks a little bit more complicated, but I see that it says less than 0. So less than 0, of course, means that I am looking for a negative value for my rational expression. So my first step is to factor my numerator, factor my denominator, and find where each, the numerator and the denominator, are equal to 0. So my numerator would be x plus 4 times x minus 1. My denominator, x minus 3 times x minus 3. And I would like that condition, that rational expression, to be less than 0 or negative. Now let's separate this into two different parts. I'm going to first of all start with my numerator. So x plus 4 times x minus 1. I want to solve this as an equation, so set it equal to 0. Making your t-bar, I see that I get x is equal to -4 and x is equal to 1. Now, when I'm looking at the numerator, I need to look at the original inequality and say, if this has an equals, then I know that these two would be part of the original solution. In this example, I don't have an equals, I just have a less than, so I know that these two are not part of my solution. So on my number line, I'm going to be putting an open circle at each of those spots. Now let's go to our denominator. I see that both factors are the same, so it's enough for me just to set x minus 3 equal to 0. And that tells me that x equals 3 is where my fraction is undefined. Now again, any place where my answer is undefined cannot be part of my solution. So that tells me that at 3, I'm also going to put an open circle on my number line. So let's make our number line. It's really not possible to do these without our number line. -4, 1, and 3. Those are the numbers that partition the intervals. They're the endpoints of the intervals. We said that all three of them were not going to be part of our solution set, so that's why we're putting an open circle for all three. Now we've got quite a bit more checking to do in our numerator and our denominator for our test points, so make sure you're following along. I'm going to pick a number smaller than -4. How about -5? Let's put -5 in for x, and again, I don't care what the answer is, I just care whether the answer is positive or negative. -5 plus 4, that's negative. -5 minus 1, that's negative. Negative times negative gives me a positive numerator in that interval. Now let's try the denominator. -5 minus 3, that's negative. Same thing for the second factor. Negative times negative is positive. But recall that I'm looking for a negative value on my rational expression, and I'm not going to pick that section because it gave me a positive value. Let's try a number between -4 and 1. Again, 0 is the easiest one to pick. So put 0 in for x in the numerator. 0 plus 4, positive. 0 minus 1, negative. Positive times negative gives me a negative numerator. Now let's put 0 into the denominator. 0 minus 3, negative. 0 minus 3, negative. Negative times negative is positive. This time, negative numerator, positive denominator does give me a negative value for my rational expression. Let's go between 1 and 3. 2 would be the best choice. 2 plus 4, positive. 2 minus 1, positive. Positive times positive, positive. Denominator, 2 minus 3 is negative. 2 minus 3 is negative. Negative times negative gives me a positive denominator. And positive divided by positive is positive, so I'm not going to color that one in. I wanted a negative rational expression. Let's look at the last part. 4. 4 plus 4 is positive. 4 minus 1 is positive, so my numerator is positive. 4 minus 3, positive. 4 minus 3, positive. I again get positive over positive. So you can't just assume that you're going to pick alternating sections here. In this case, here's one where only one of the sections worked. If I'm putting this in interval notation, I'm going to give my answer as open parentheses, -4 to 1, close parentheses. If I'm giving it in set builder notation, that's going to be x such that x is greater than -4, but smaller than 1. X falls between -4 and 1. Now, looking at number 2b, we see that it's got a little bit of a change here. I don't have my expression less than or greater than 0. Instead, there's a 5 there. So I'm going to have to change this expression and put it in standard form so that I have a 0 on the right side. So that means that I've got to subtract 5 from both sides of my inequality. So it's going to look like this. Now, in order for this process to work, I'm going to need a common denominator. So I see that my common denominator is x minus 8. So we're going to multiply the 5 by x minus 8, both on the top and the bottom. Remember, finding our common denominator. So on the left side, I've got x over x minus 8 minus 5 times x minus 8 all over x minus 8 is less than or equal to 0. Now let's go ahead and distribute and then combine like terms. So I'm going to have x minus 5x plus 40 all over x minus 8 is less than or equal to 0. Combining like terms, that gives me negative 4x plus 40 all over x minus 8 is less than or equal to 0. Now, just like our previous examples, we want to set our numerator equal to 0. So negative 4x plus 40 equals 0. Move the 4x over, so 4x equals 40, and x is equal to 10. So that's one of the endpoints of our intervals. This is where my numerator is equal to 0. And when I look carefully, yes, I would like that answer to be in my solution set because I do have an equals. So that tells me on my number line, this number is going to be filled in. So let's look at the denominator. X minus 8 equals 0, where it is undefined. So x is equal to 8. Now I can never have an undefined result, so therefore I'm going to say make an open circle at 8. Make our number line, and the only two numbers on there are 8 and 10. We see that 8 has an open circle and 10 has a closed circle. Every single time I set a denominator equal to 0 and I make my rational expression undefined, that value will not be part of my solution. So that's why I'm putting an open circle at 8. Now let's test each number, and when I'm testing in this newly written inequality. So I'm going to test, for example, let's try 0. That would be to the left of 8. When I put 0 into the numerator for x, I'm getting a positive numerator. 0 into the denominator is giving me negative. Positive divided by negative is negative, and that's exactly what I'm looking for. I'm looking for a negative value on my rational expression. So I am going to color that section right there. Try the number 9. So when I try 9 for x, my numerator is giving me positive. My denominator is also positive. So positive divided by positive is positive, and that's not part of my solution set. Now pick 11. Negative 44 plus 40, that's a negative numerator. Positive denominator. So negative divided by positive does give me a negative answer. So I've got those two sections on my number line. In interval notation, I would go from negative infinity to 8, but don't include the 8. Then I also want to go from 10, but I do want to include the 10, all the way to infinity. In set builder notation, this would be two separate sets. X such that x is less than 8, or x is greater than or equal to 10. Let's try one more rather complicated example for number 3 together. X minus 1 over x plus 2 over x plus 3 is less than 3/2. Now for this one, I see that I've got to put together these fractions into one rational expression. So I'm going to start by moving the 3/2 to the left side, and then I'm going to have to go ahead and look for my common denominator between the three fractions. So let's subtract the 3/2, and that would leave me with less than 0. Now when I look at this carefully, I see that my least common denominator is going to have a 2 and an x and also an x plus 3. So what am I missing in the first fraction? I'm missing the 2. And we also need the x plus 3. So let's multiply the numerator and the denominator by 2 and by x plus 3. The second fraction is missing the 2 and the x, so we're going to multiply the numerator and denominator by 2x. The last fraction is missing the x and the x plus 3, so let's multiply the numerator and denominator by both of those. Now, this is where the algebra is a little bit complicated. I'd like you to pause the video and do that distribution and come back and check and see if you got the same fractions that I got. So please check your multiplication and notice in the numerator of the first fraction, I got 2x squared plus 4x minus 6. The second fraction, 2x squared plus 4x. The third fraction, I'm going to subtract 3x squared and 9x, so both of those get negated. Now, putting together your like terms, I'm getting an x squared minus x minus 6 in the numerator. Notice that in the denominator, I left it in factored form. That's going to help me solve for where the denominator is equal to 0 or where the rational expression is undefined. So let's go ahead and set our numerator equal to 0. So that numerator can be factored into x minus 3 times x plus 2. Do the t-bar, and I see that I get x is equal to 3 and x is equal to negative 2. Since my original inequality does not have an equals on it, that tells me that both of these values are going to have an open circle on my number line. Now let's set the denominator equal to 0. So 2x times x plus 3 equals 0. That's giving me the two values, x equals 0 and x is equal to negative 3. Again, both of those are not part of my solution set, so I'm putting open circles for both of those as well. Let's make our number line and put all of those values on our number line as partitions. So I see that I'm going to start with negative 3, then I've got negative 2, then I've got 0, and the last value is 3. All of them have open circles, not part of the solution set. Now we want to go back and test in this expression. For the numerator, I would probably use the factored expression to decide whether I've got positive or negative. I am looking for a negative value on my rational expression. So let's go ahead and pick negative 4. Putting negative 4 in for x, I'm going to have a negative times a negative, so the numerator is positive. Putting a negative 4 into my denominator, 2 times negative 4 is negative, negative 4 plus 3 is negative, negative times negative is positive, so positive divided by positive does not work, so I'm not going to color that part in. Let's pick negative 2.5 in this section. So in my numerator, negative 2.5 in for this x is negative, also negative here. So negative times negative is positive. Put negative 2.5 in for this x, so I'd get a negative and a positive, so therefore my denominator is negative. Positive divided by negative is negative, so I'm coloring in that section. And in interval notation, I'm going to say let's keep the negative 3 to negative 2 with curved brackets on both ends. Now let's try negative 1 in this section. Negative 1 minus 3 is negative. Negative 1 plus 2 is positive. So that gives me a negative numerator. Negative 1 times 2 is negative, times positive is also negative. Negative divided by negative is positive, so I don't want that section. Pick this section. How about the number 1? So here I'm seeing that 1 minus 3 is negative, 1 plus 2 is positive, so that gives me a negative numerator. Testing the denominator, I'm getting positive times positive, which is positive. Negative divided by positive is the right answer, so I want this section, so that goes from 0 to 3. And when I check my last section, how about 4? Positive, positive, positive numerator. Denominator, positive, positive, positive denominator, and that will not give me a negative solution. To put this in set builder notation, it would be two different sets. X such that x is greater than negative 3 but smaller than negative 2, or x is greater than 0 and less than 3. Obviously, the interval notation is much easier to write down, but it depends what you're asked for. Now I'm going to have you go ahead and look at the You Try It and do that problem and then come back and check your answer with mine. So fill in this You Try It example on the last page of your notes and then go ahead and solve it. You can compare your work with my work and see if you got a similar result. In simplified form, I got my numerator to be x squared minus 2x minus 8 over x. When I factored the numerator, it was x minus 4 times x plus 2. So that gives me the two solutions, 4 and negative 2, for where the numerator is equal to 0. Because my original inequality did have an equal sign, that told me that both of those points are going to be part of the solution set and have a solid dot. The denominator was just an x, so when I set the x equal to 0, that gave me a point that would not be in the solution, but it's going to be one of the partitions of my intervals. Taking a look at all of my sets, I see that the two sections that do work are this section back here from negative infinity to negative 2, and this section here from 0 to 4. Notice that when I have a solid dot, that's going to be shown as a square bracket on the end of my interval. When I have an open dot, that tells me that that's going to be a parentheses at the beginning of 0. We're going to work a whole lot more with these in class. If you have any questions, please feel free to come and ask, and I can go over it with you again. This is a very tricky topic and there's a lot of things to pay attention to, so it's really important that you've really paid attention to this video tonight. We'll see you tomorrow. Have a great night.